Okay, this is problems number 10 and 11. Find the exact value of the expression. Both of these problems are going to be done in a similar fashion. So once you understand one, I think the other one will be easier for you. So I don't know any value of 13 pi over 12. If I look at the unit circle, that's not going to come out. So that gives me an idea that I'm probably going to have to use either the sum or the difference formula to figure this out. Another thing is 13 pi over 12 is kind of hard to work with. So if I turn 13 pi over 12 into degrees, it might give me more of an idea what I need to do. So to turn something into degrees, I take 180 degrees over pi. And when you simplify this down, it ends up being 195 degrees. All right, so now I'm looking for tangent at 195. And because this expression or this value ends in a 5, I'm going to go ahead and assume that 45 is one of the values. So if I take 195 less 45, I get 150. This is a value I know. So I can rewrite this as tangent 150 degrees plus 45. Now all I need is the formula that goes with it. So the formula that allows me to add these two values together is tangent alpha plus beta equals tangent alpha plus tangent beta all over 1 minus tangent alpha times tangent beta. Okay, so alpha is your first term and beta is your second term. So let's go ahead and plug and chug. Tangent of 150 degrees plus 45 degrees equals tangent alpha, which is 150, plus tangent beta, which is 45 degrees, all over 1 minus tangent of 150 degrees times tangent of 45 degrees. So now that we have everything plugged in, we just have to evaluate it. Okay, so if you use the unit circle, or if you use the triangles, the reference angle, if you're going to use a triangle, would be 30 degrees. And just remember that tangent is negative in quadrant 2. So basically, when I do this, I get tangent of 150 is negative radical 3 over 3. Okay, plus tangent of 45 is 1. Then 1 minus tangent of 150 degrees, again, is negative radical 3 over 3. Times 1. Okay, now I'm at the point I need a common denominator. So in the numerator, the common denominator is going to be 3. So I'm going to change that 1 to 3 over 3. So when I do that, I get negative radical 3 plus 3 over 3. That's the numerator. In the denominator, I'm going to get 1 plus radical 3 over 3. So once again, finding a common denominator, I'm going to get 3 plus radical 3 over 3. Now, let's make this look a little bit better. So negative radical 3 plus 3 over 3 times 3 over 3 plus radical 3. We can simplify the 3's down, those go away. So I'm left with negative radical 3 plus 3 all over 3 plus radical 3. Unfortunately, I cannot cross these out because they're binomials. The only way you can simplify a binomial is if it's exactly the same. If you look on the answer key though, this answer doesn't show up. So that means we're going to have to do something. We're going to have to rationalize this. So I'm going to go ahead and do that on the next slide. So once again, we had negative radical 3 plus 3 over 3 plus radical 3. Now, to rationalize it, I'm going to go ahead and take the conjugate of the denominator. So that's going to be 3 minus radical 3. And what you do to the bottom, you do the top. Why? Because it's like multiplied by 1. And then in the denominator, I have a difference of perfect squares. So 3 squared is 9. Radical 3 squared is 3. So I get 9 minus 3, which is 6. Okay, so denominator taken care of. The numerator, you're going to have to FOIL that out. So we're going to have to FOIL this out, and we're going to get negative 3 radical 3. And then I'm going to distribute negative radical 3 times negative radical 3, and I'm going to get plus 3. And then 3 plus 3 is 9, or 3 times 3, I meant to say, is 9. And 3 times negative radical 3 is negative 3 radical 3. Combining like terms, I get negative 6 radical 3 plus 12. All right, I can take a 6 out of that. So take the GCF of 6 out of the numerator, and I get negative radical 3 plus 2 all over 6. I can now simplify that down, and my answer is now 2 minus radical 3. And if you look at that, you'll see that is the same answer as A. Okay, so that one's done. Let's go ahead and check out number 11. So number 11 has the same directions. Find the exact value of the expression, and I'm given sine of 165 degrees. Okay, so I look at this. I know it ends in a 5, so more than likely I'm going to have a 45-degree angle somewhere involved. So if I take 165 minus 45, I get 120. Okay, I know what sine of 45 degrees. I know 120 as well. This is on the unit circle, so I'm good to go. So now let's rewrite this as sine of 120 degrees plus 45. And we're going to use the formula sine alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. So I ran out of room there. Okay, so I'm going to go ahead and plug and play. So sine of 120 times cosine of 45 degrees plus cosine of 120 times sine of 45 degrees. So there you have it. Now all we have to do is evaluate. So once again, you can use the reference angle of 60 degrees on the triangle and 45 degrees on the triangles, or you could use the unit circle. If you use the unit circle or the triangles, you will find that sine of 120 degrees is radical 3 over 2 times cosine of 45 degrees is radical 2 over 2 plus cosine at 120 is negative 1/2 times sine of 45 degrees, which is radical 2 over 2. Okay, if I multiply these together, I get radical 6 minus radical 2 over 4. Now, if I look on the answer key, that is not available. So what do I have to do? Well, if you notice, I had a radical 2 here, and a common denominator of 4. So if I factor out a radical 2, I'm left with radical 3 minus 1 all over 4. And that answer corresponds with letter D. And that is the correct answer. The answer key is wrong. So number 11 should be answer D. And this is my answer. Okay, and I'll go ahead and square off the one next to it. All right, so that was number 10 and 11.